learning platform, that is BYJU'S Exam Prep, everyone. And how are you all? How are you, everyone? Welcome you all to the India's most comprehensive live learning platform, that is BYJU'S Exam Prep. And in the today's session, we are going to be discussing a very important topic from transportation engineering, that is your signal design using Webster's method. So in GATE syllabus, we only have Webster's method. And you will find a question from this topic every year in every GATE examination. So for the GATE examination, this is a very important topic, guys. For the GATE examination, this is a very important topic. In the today's session, guys, we are going to be discussing in detail all the basic terminologies and what is Webster's method and how to find out optimum cycle length using Webster's method. We are going to understand each and every concept in detail in the today's session. So it is going to be a very important session, guys. Even if you are watching after the session has been uploaded, okay, even if you are watching live, I want you to watch from the starting till the end, because if in case you miss even a single concept in between, you will not be able to understand further concepts. So you have to watch the whole session in a flow. Okay, you have to start from the first minute and you have to watch till the end. Okay, because if you leave in between, or if you come back in, if you join in between after starting the session, you will not understand what is going to go next. Okay, so all the concepts are going to go in a flow. Each and everything is important in the today's session, and all the things are very basic in nature. And you are going to love the session, because this is something you will find very interesting in nature. Okay, this is something that you see in everyday life. Okay, you must have been standing at any traffic signal and might be wondering on what basis do we design these traffic signals. How do this, what is the time, what does it, on what basis do we design the timing of any red signal or green signal or amber signal. Okay, what are the technicalities behind it. We are going to understand each and everything in the today's session. So let us start our session, guys. So firstly, you all know me, my name is Rohan Goyal. Okay, so we will start, we'll quickly go forward, and I will provide the PDF in my Telegram group, Civil by Rohan Goyal. So you can join my Telegram group, Civil by Rohan Goyal. I will be providing you all the PDFs and the notes which I take on my session on my YouTube. Okay, and I'll also be doing personalized doubt resolution through Zoom. Personalized doubt resolution through Zoom. Okay, so I'll be taking personalized Zoom sessions as well. So you can also be a part of those Zoom sessions in which I will be clearing your doubts through personalized Zoom sessions, everyone. You can also use this link in order to join my Telegram group. Either you can search Civil by Rohan Goyal, or you can also use this link, everyone. So what is the content of the today's session, guys? In the today's session, we are going to be discussing what is a traffic signal, what is a phase, what is time lost, some common terminologies, and then we will go to the Webster's method. All these things are very important, and then only you will be able to understand Webster's method, until and unless you have clarity over all these topics. If you do not have clarity over any of the single topic of the above, you will not be able to understand what is Webster's method. Okay, so let us start one by one and keep on enjoying the session. Okay, keep on listening to me, and you can also make notes alongside, so that you can revise it afterwards also. I can assure you, from this single session itself, you will be able to solve all the numericals from the Webster's method which has been asked in the GATE previous years. Right? Hello Viresh, welcome. Join fast everyone. Again, I would like to tell you, everyone, that watch the session from the start till the end in a flow. Do not skip in between. Each and every concept is linked in the today's session. Each and every concept is important in the today's session, and if you watch the whole session in a row, then only you will be able to get the full understanding of the Webster's method. Okay, otherwise you will be asking me after the session, sir, I have studied Webster's method, but I am not able to solve the questions. Tell me why am I having such an issue? Sir, I have studied the Webster's method, but I am not able to understand the problem. What the problem is asking me. Why is it happening with me? This is the reason why it happens with you, because you lack patience. You are having less patience. You cannot sit for such a long duration to get the fruit, right? So you have to sit with me. Are you ready to enjoy the full session along with me without anyone going out? Are you all ready, everyone? Yes or no? Are you all dedicated enough to learn Webster's method today? Yes or no, guys? So you have to give this assurance to yourself, okay? You have to give this assurance to yourself, everyone. Let us start, guys. So the first thing that we are going to see, what is a signal consist of? So traffic signal consists of red signal, amber and green. So they have separate times which are referred to as red time, amber time and green time. As we all know, red time indicates stop. So this indicates stop. Green time indicates go. And amber time indicates it's a clearance interval. It is referred to as clearance. So it is allowing the traffic which is there to clear the intersection. So it is also referred to as clearance time. Okay. Now, what is the cycle length? So cycle length is a total duration which is available with the traffic or which is available with that phase. So the cycle length in our case will be, for example, total red time plus amber time plus green time. So total cycle length is amber time plus red time plus green time. Okay. So this is a complete cycle of indication. It is a full cycle of indicate. It is also indicates. So suppose you are at a traffic light, okay, and you see a green signal. Once you see a green signal, what is the next time when you again see the green signal is your total cycle length. Okay, so that is a total cycle length. So it will consist of, so first I will explain this. Okay, then we have this clearance interval. I will come back to this one once again. Okay, let us understand what is phase. So there are different phases in which the signal may be designed. The signal may be designed in a two-phase system or a four-phase system or even more than that. So let us take an example. Suppose you have an intersection like this. Let me take another color. Okay, let us say we have an let us take an example of a two-phase system. Let us take an example of a two-phase system. So in this, for example, in a two-phase system, we are providing only, there is only traffic which is going in a straight direction. Okay, there is no turning traffic. Okay, there is no traffic which wants to take a turn. There is only traffic which is moving only in the straight direction. So it may be like this. One phase. So you are allowing the traffic to move in this particular direction. Let us call it as east-west direction. Let us call this as east-west direction. And this is your phase 1. This is phase 1. And the other phase would be you are allowing traffic only in this north-south direction. Like this. So this is a two-phase system. This is a two-phase system. Similarly, you can also have, now let us first of all indicate how would the traffic lights will look like in a two-phase system. So let us understand this. So this is corresponding to phase 1 and this is corresponding to phase 2. Okay. Now in the phase 1, when you have a green light, okay, after green light you will get amber light, and after amber light you will again get red light. What will happen when you have a green light and amber light in phase 1? What will be the light in the phase 2? Can anyone tell? When there is green light over here, when there is green light in this signal, when there is green light in this phase, in this traffic movement, what will be the light in this phase? Can anyone tell me? Can anyone tell me? Yes or no? Can anyone tell me what will be the light in the other phase? Yes guys, isn't it going to be red? Okay, when this traffic movement is allowed, this traffic movement will be restricted. That means this is going to be in red in color. So this portion of the region will be under red. The phase 2 will be in red when these two are in green and amber, and then you will get green, and then after that you will get amber. Okay, now what is a phase? A phase is the total time of the full cycle. The phase is a part of the full cycle length which is available by the traffic for the movement. So in this case, what is the time available by the traffic in the phase 1 to move? That is green plus amber. Yes or no? Traffic is able to move in green plus amber only. Red is not the time for the traffic to move. So the phase will be referred to as green plus amber plus clearance light time or all red time. What is clearance time? Let us understand. Clearance time is also referred to as, see what is clearance time? No, let me explain. So at the end of amber time, after amber time is completed, there will be some duration which will be red for all the phases. Okay, that means you are allowing the vehicles which are there inside the intersection to go out. So you are providing some additional time which is referred to as clearance time to allow the vehicles which are there inside the intersection to go out. First reason. Second reason could be you can use this all red time or clearance interval to allow any pedestrian movement. Okay, after suppose you are standing in the, you are traveling in a vehicle, you see an amber light, you stopped. After that you saw the red light, you saw some pedestrian walking. After the pedestrian has gone, then you are seeing that the other phase is moving. So what is that time in between? That is all red time. That means all the traffic is stopped for the movement of the pedestrian. That is referred to as clearance interval. So it is included after each yellow interval, that is amber. Okay, indicating a period during which all signal phases shows red. That means all the signal phases are in a stopped position right now. And it may be also used for pedestrian movement also. Okay, now for example, if in this particular case only you have this all red time, if you have this all red time clearance interval, so how would it look like? Let us understand. How would it look like? How would this look like? Let us understand. See, tell me everyone, any doubt up to this point? Any doubt of anyone up to this point, guys? Any doubt up to anyone up to this point? Are you able to understand this diagram? Are you able to understand this signal diagram, how the signals are changing and how it is represented for different phases? Is it clear to all? If there is any doubt, comment in the chat section. I will refer to your comment. This is phase number 1. This is phase number 2. Okay. Now let us see how this all red time is shown over here. Now suppose this is your green time. Then after green time your amber time will be here, and after amber time your red time will start. Okay, now in the other lane your red time is here. This is your red time. Okay, this is your red time. Then you have your green time, and then your amber time. Okay, now look over here, what happened. Okay, so this is green time, this is amber time, and after amber time this lane is also red and this phase is also red. So this portion over here, this portion over here is all red. Yes or no? This portion over here is all red. Then after this green time has started, amber time has started, and then again red has started over here and red is over here also. So this is also all red. So these two are all red time. Okay, these two are all red time. And this time is allowed for the vehicles which are there inside the intersection to clear the intersection. Okay, you have to provide some time for the vehicles which are there within the intersection only, but they have not cleared the intersection. You have providing this time for them to clear the intersection. Is it clear to all? Is it clear to everyone? So phase length is a part of the total cycle length in which traffic movement is allowed, which is green time plus amber time plus clearance time or all red time. Okay, moving on. Right. Now there is some time lost also. Now what is this time lost? Okay, so there are two types of time lost. Okay, when there is the time of the cycle length which is not effectively utilized. The time of the cycle length which is not effectively utilized will be called as a time lost. Now this time lost are of two types. Okay, one time is lost during the beginning of the green light. When you just see the green light, when you are standing on the traffic and you just see the green light. So some amount of the time is lost during that time. And some time is lost at the end of the amber time. The time lost at the starting of the green time is referred to as startup time lost. Now suppose you are standing at the traffic. You are standing at a signal, right? And you are having a red light. So as soon as you see the green light, you will press the accelerator and you will move your vehicle. But while doing so, there will be a lag of 2 to 3 seconds. Right? You will perceive the signal. You will there will be emotion, then there will be volition, right? So it will take 2 to 3 seconds to act. So this reaction time over here is lost because the traffic is not moving during that time. Okay, you are not utilizing the green time because there is some reaction loss. Okay, so this time lost during the starting of the green time is referred to as startup time lost. Okay, when the signal turns red to green, the driving standing very near to the intersection usually takes some time to perceive the signal, which is referred to as the reaction time, and hence some time is lost. Similarly, when the amber is going to end, when the amber sign is going to end, red sign will come. Okay, but the last few seconds of the amber time are not utilized by the traffic because traffics have already crossed the intersection. Okay, because the vehicles have already crossed the intersection. Last few seconds are not utilized by the vehicles. So some amount of the time is lost, which is referred to as clearance or movement lost time. Clearance or movement lost time. Okay. Now this is also referred to as all red time. Okay, this is also referred to as all red time. Why? Because all red time is also a time which is lost by the vehicles to move, right? No vehicle is able to move in the all red time. So clearance lost time or movement lost time or all red time are one and the same thing. Clearance lost time, movement lost time, all red time are all the same thing, right? So it is also referred to as all red time. Any doubt to anyone? Any doubt to anyone? Any doubt to anyone? So total lost time will be equal to, total lost time will be equal to, total lost time will be equal to total lost time will be equal to startup lost time plus clearance lost time. Okay, now this can be a full cycle also, okay, or it can be written as per phase also. So like this, startup lost time per phase is equal to total lost time per phase is equal to startup lost time per phase plus clearance lost time per phase. Okay, understanding these basic concepts is more important than knowing the Webster method. If you do not understand all these basic concepts, you will not be able to understand the Webster's method. And again, I am telling you, all the concepts are very important. Whatever I am telling you over here is each and every word is important. And if you are missing even a single concept in between, you will not be able to understand what I will tell next. Okay, so the things are going to get more and more interesting. Okay, I hope you are enjoying the session up till now, and if you are enjoying the session, do subscribe to the BYJU'S Exam Prep channel and share the session as much as you can. All right, so this is the lost time per phase. This is the totalized lost time for the full cycle. This is for full cycle. All right, now what is effective green time? Now, if out of the total duration which is available for the traffic to move, some amount of the time is lost. So, effective green time is referred to as total green time plus amber time minus lost time. Total minus time lost, which is equal to green time plus amber time minus startup lost time plus clearance lost time, which is also referred to as all red time. Any doubt to anyone up to this point? Any doubt to anyone up to this point? Yes or no? Any doubt to anyone up to this point? Moving on. Now, what is saturation capacity? In order to understand this, we need to understand startup lost time even in a further little bit more detail. Let us understand. Suppose you are standing at an intersection, okay, and you are finding you just see that the light has gone to green, right? So this is the vehicle, okay, so and this is your time headway. So the time required for the vehicle to react, okay. So initially the first vehicle is going to take the maximum time to react, right? The first vehicle is going to take the maximum time to react because he is going to perceive the signal. Initially he is going to perceive the signal and he is going to accelerate, okay. So he is going to take maximum time to react. The vehicle which is standing just behind him is going to take little lesser time to react. The vehicle which is standing behind this one is going to take further lesser time to react. The vehicle which is standing behind this one is also going to take further lesser time to react. And similarly, the time headway is going to reduce like this. Okay, and at the end you are going to see that there is a constant headway of small h. There is a constant time headway of small h. That means when the traffic, all the vehicles are moving at the same speed, they are all moving freely at the intersection of the green light has been seen, still there is a little time headway which is constantly there. Okay. So what will be that means at that intersection the maximum flow could be, maximum saturation will be equal to, so this is 3600 divided by h. So this will be the maximum flow of the vehicles. This will be the maximum flow of the vehicles. Yes or no? Yes or no, everyone? This will be the maximum flow of the vehicle. Any doubt to anyone? Any doubt to anyone, guys? Yes or no? All right. So if this is the maximum flow of the vehicle, green ratio is defined as effective green time divided by cycle length. So this is the maximum flow when all the vehicles are moving freely. So how much traffic can actually be accommodated? It will be equal to G by C into saturation capacity. Green ratio is the effective green time of the cycle length which is available for the movement into saturation capacity is your traffic capacity, and traffic flow is the actual traffic which is flowing at that intersection. This is the maximum capacity and this is the actual value. This is the maximum capacity, this is the actual value, this is the saturation capacity which is not taking into consideration any restrictions. Okay, this is taking into consideration the effective green time. This is the actual value. All right. Now all the terminologies have been understood. Now we will go into the Webster's method. So Webster's method is the most rational method up till now for the design of signals. Okay, so it is the most rational method for the design of traffic signal. Okay, in this method we are going to get an optimum cycle length. Why do we refer to as the optimum cycle length? Why do we refer to as the optimum cycle length? Why do we refer to as the optimum cycle length? Any doubt up to this point to anyone, guys? Any doubt up to this point and to anyone? Yes, everyone? Any doubt to anyone up to this point? So this is the most rationalized method for the traffic signal design, and the Webster's method is referred to as the most optimum cycle. It gives us the optimum cycle length. Why? So it has been seen experimentally by doing experiments at the traffic intersection. So if the cycle length this is your optimum cycle length, and with this optimum cycle length you will get the minimum delay, average delay. So at this optimum cycle length you will get minimum delay. If you reduce the cycle length, your delay will increase. If you increase your cycle length, your delay will again increase. So at this cycle length, as per this formula of Webster's method, you are going to get the minimum cycle length. Okay. So this is what I have written. Optimum cycle length is the length with which the average delay is minimum. Okay. Average delay is minimum. Clear, guys? Now let us understand what is the formula of Webster's method for cycle length. Optimum cycle length is equal to 1.5 time lost plus 5 upon 1 minus y. Okay, so where suppose it is a n phase system. Suppose it is a n phase system. So y is equal to y1 plus y2 plus y3 up to yn, where y1 is equal to q1, which is traffic flow in that phase 1, traffic flow in the phase 1 divided by saturation capacity of phase 2. y2 will be equal to q2 by s2 and so on and so on. Okay, what is L? What is L? It is equal to time lost per phase. Okay, time lost, total time lost, sorry, not per phase, total time lost, total time lost. Total time lost, which is equal to number of phases multiplied by startup lost time per phase plus clearance lost time all or all ready time per phase. Okay, if you are not given startup and clearance lost time, it can also be written as 2 times n plus ready time or all ready time, where n is your number of phases. And this is your all ready time. One note point over here. One note point over here. If all ready time is not given, if all ready time is not given, use all ready time equal to amber time. If all ready time is not given, use all ready time equal to amber time. All right, if all ready time is not given. So what do you understand over here? Okay, y is equal to y1 plus y2 plus y3 up to yn, where y1 is equal to q1 by s1, q2 by s2 similarly. Okay, L is your total lost time, which is equal to startup lost time per phase, clearance lost time per phase, or all ready time per phase into number of phases. Or you can also written as 2 times number of phases plus all ready time. That means your startup lost time is taken as 2 seconds. Over here, your startup lost time is taken as 2 seconds. All right. So this is your formula. Now, what is the green time available with any phase? Suppose effective green time with phase 1. Let us calculate effective green time with phase 1, that is G1. So effective green time with phase 1 is equal to, so first of all, what is the effective cycle length available? C naught minus L. So this is the optimum cycle length minus total lost time. Okay, so only this much of cycle length is available for movement. Okay, out of this, how much will be available with the effective? y1 times this, which is equal to q1 by s1, sorry, y1 divided by capital Y. y1 divided by capital Y, like this. Okay. Similarly, effective green time available with the second phase, y2 divided by capital Y into C naught minus L, then G3 Y3 divided by capital Y C naught minus L, and similarly we can find out effective green time for all the phases. All right, clear guys? Everyone, is it clear to all? Yes or no? Okay, now let us solve one problem over here. Now this is a very recent problem from a GATE 2022 paper which was asked for 2 marks. You will find this kind of a problem in every year in GATE, right? So let us understand the problem first. Okay, let us understand the problem first. So our lane configuration with the lane volume in a vehicles per hour for 4-arm signalized intersection is shown in the figure. So you are given a 4-arm signalized intersection and the lane volume is given to you in each lane over here. Okay, there are only 2 phases, so it is a 2-phase system. It is a 2-phase system. The first phase is for the east-west and the west-east through movement. So this is east-west. So the first phase is for this through movement. Okay, and the second phase is for the north-south and south-north through movement. So this is the second phase. There is no turning movement allowed. No turning movement is allowed. Assume that the saturation flow is 1800 vehicles per hour per lane. 1800 vehicles per hour per lane. These are given in per hour, vehicles per hour. Vehicles per hour is given. Okay. Now, the total lost time for the first and the second phases together is 9 seconds. So, total lost time is given. Total lost time is given. If in case per phase was given, you have to multiply it with the number of phases. Over here, you are given total lost time for both the phases together. So, you will take L value equal to 9. You will take L value equal to 9. Otherwise, if it is given per phase, you have to multiply it with the number of phases. You are asked to calculate what is the optimum cycle length in seconds as per the Webster's method rounded off to the nearest integer. Can you calculate this question? So first of all, I would like to ask you the question that first of all, you will have to find out what is Q1, what is Q2. S you are given 1800 vehicles per hour per lane. Okay. Q1, Q2 is required, L is given. So what is Q1? Can anyone tell me? This is phase 1. This is phase 1. This is phase 2. What is Q1? Can anyone tell me what is Q1? Can anyone tell me what is Q1? Yes, guys. 504 or 460 or 440. Which value you are going to take? 504, 440 or 460. Which of these values you are going to take as Q1? Tell me. You will take maximum value because you have to design for the maximum flow. So maximum you are going to take. Maximum you are going to take. So I will take 504. I will take 504 as the maximum value. No, you will not take the minimum value. You will take the maximum value. You will take the maximum value. So it will be taken as 504 vehicles per hour per lane. Similarly, tell me Q2. 396, that is 396 and 360. Which of the two values you are going to take as Q2? Which of the two values you are going to take as Q2? Yes, everyone. 396, very good. 396 vehicles per hour per lane. So, can you calculate Y1 and Y2? Y1 will be equal to 504 divided by 1800. Y2 will be equal to 396 divided by 1800. Y will be equal to y1 plus y2. Okay, then optimum cycle length will be equal to 1.5 into 9 plus 5 divided by 1 minus y is equal to how much? Calculate and tell me the answer. What is y coming out to be? It will come out to be 0.5. 0.5. So if you simplify this, "37 seconds will be your optimum cycle length." Your optimum cycle length is 37 seconds. Now suppose if further it is asked, what is the effective green time for phase 1? Effective green time for phase 1. So you will do y1 by capital Y, C naught minus L. So y1 is equal to 504 divided by 1800 multiplied by capital Y 0.5 into 37 minus 9. Calculate how much value you are getting over here. What is the effective green time for phase 1? .68 second, and effective green time for phase 2 will come out to be equal to 37 minus 9 minus 15.68, which is equal to 12.32 second. Any doubt to anyone? You can calculate this. You will get the same value from y2 by y, C naught minus L. You will also get the same value from there as well. Is it clear to all? Is the concept clear to everyone? Okay. So now we are finished with our session. You can ask me if there is any doubt. If there is anything you would like me to repeat from the today's session, I will repeat. If there is any point you want me to repeat, Viresh and anyone else, if you want me to repeat any of the point, I can repeat for you guys, or we wind up of the session. Tomorrow I'll come up with another session on traffic flow studies. Traffic flow studies. .2 you are getting. No, you should get this same value only. 12.32 you should get. I'm getting 12.32 exactly. Viresh, kindly check your calculation. Alright, so with this I'll wind up on my today's session, guys. So do subscribe the channel, guys, everyone. Subscribe to the BYJU'S Exam Prep channel and click on the like button and share the session as much as you can. This is a very important session, and do not forget to watch the session from the starting till the end. It is a very important session, and if you leave in between, you will not be able to understand any of the concept. Okay, you will skip the flow of the concepts. Okay, thank you everyone. Take care. See you in the next session, guys. Bye everyone.